Hello, my name is Victor Ionin, founder of SCDO, also known as SCDO. Today, I want to introduce the SCDO project and how it impacts the blockchain community. I'll talk about SCDO's sharding technology, STEM subchain protocol, and consensus algorithm. First, let's do a quick comparison on the transactions per second TPS. We all know Bitcoin runs roughly around 2 to 3 TPS, Ethereum peaked at roughly 15 TPS, and Visa and MasterCard at roughly 1700 TPS. To be used as a commercial decentralized electronic payment system, the TPS has to be comparable to Visa and MasterCard's. Before we can talk about how SCDO is planning to achieve that, I first need to explain sharding. You might be wondering, what is sharding? And I'll explain it to you via an analogy. Think of blockchain as a busy freeway with one toll gate that every car, which represents a block, has to go through. This layout can cause a lot of traffic since every car has to pass through that toll gate. Blockchain sharding is like adding more toll gates. For example, by adding 3 more identical toll gates, you can have 4 times the number of cars passing on this freeway. SCDO's sharding technology combines the characteristics of P2P network sharding, transaction sharding, and account state sharding. Sharding is implemented on-chain, and each shard is completely replicated and equivalent to each other. Each shard stores the minimum information of other shards to ensure the verification of cross-shard transactions. The SCDO sharding protocol ensures that the SCDO mainnet can add more shards at a minimum cost when needed. SCDO sharding will easily reach 1,000 transactions per second. This will change people's perception of the low efficiency of cryptocurrency as a payment method. With an increased throughput, more applications can be deployed on SCDO. Sharding can also increase the number of blocks generated per unit time, making mining more profitable and attracting more nodes to join the network. Lastly, sharding will reduce transaction costs because it reduces the time it takes to verify a transaction. Low transaction fees and high transaction speeds will attract more users. The basic idea of sharding is partitioning the mining nodes, the accounts, and the network into shards. SCDO mainnet is currently configured with 4 shards. When creating the pair of public and private key of an account or a node, the creator can tell SCDO which shard it belongs to. Each shard has its own blockchain, which we call the local chain, to record blocks with our consensus algorithm. And each shard has a light chain to record block headers for each of the other shards. Transactions within the same shard, called inter-shard transactions, are recorded in a local chain as usual. Verification is straightforward. A transaction between 2 shards, called cross-shard transaction, is a bit more complex. The cross-shard transaction verification on the sender's shard is performed the same as an inter-shard transaction. Now, the cross-shard transaction verification on the receiver side is a big challenge because validators in the receiver shard do not have the sender's information at hand. Now, this is where the light chain comes into play. The validators send a request to remote peers to retrieve the desired information related to the cross-shard transaction and carefully examine the response against the light chain. If passes, the transaction completes. Fails, and the transaction is rejected. Next, let's talk about SCDO's innovative STEM subchain protocol, also known as SSP. The SSP is a layer 2 protocol. By applying this protocol, a user or a group of users can create their own blockchain, a SCDO SSP subchain. This subchain is attached to the main chain by a smart contract. Think of it as small branches, which are the subchains, connected to the main trunk of the tree, SCDO mainnet. A SSP can have its own consensus algorithm. Currently, SSP provides two consensus to choose from, PBFT and POS. The TPS can be as high as needed. A SSP can have its own ecology and support different apps. SCDO main chain will provide the important security guarantee to an SSP by requiring the subchain to submit its state data periodically. And a user in the subchain can submit challenges if he or she thinks there are errors in the subchain transactions. Next, I'll talk about building a DeFi app in SCDO ecology. As mentioned earlier, SCDO ecology consists of the main chain and subchains. Each subchain may have its own ecology and crypto token. When a subchain is created, the creators are required to deposit a certain amount of SCDO tokens in the main chain. Now, the deposit plays a role in the security management of the subchain. The subchain's initial token offering has a natural price induced from the deposit in measure of SCDO, and the initial exchange rate between SCDO and the subchain token can be calculated. With a defined exchange rate between SCDO and each of the subchain tokens, a Uniswap type DeFi trading app can easily be built. Finally, I want to talk about SCDO's consensus algorithm. For context, consensus to me is the soul of a blockchain. Without a consensus mechanism, there is no decentralization, and blockchains are just another piece of software to manage data. The consensus algorithm used by a blockchain reflects the economic model of its ecology. The SCDO network adopts the account balance model and uses its innovative proof-of-work consensus algorithm, which we call ZPOW. ZPOW is a scientific computation-based algorithm that is CPU-friendly. The block is 1 megabyte, the same as Bitcoin's. The ZPOW algorithm computes a small matrix and its determinant. If the determinant is greater than or equal to the given target, then the solution is found. The steps to compute the matrix cannot be parallelized. It uses a series of verifiable, random numbers to generate the vectors of the matrix. ZPOW is very CPU-friendly. We do not see any mining advantages from GPU and ASIC devices. With these characteristics, SCDO mainnet is less likely to be dominated by a few miners, and therefore result in a more decentralized and stable network. We are working on a novel POW framework, a consensus computing engine that can combine multiple computational targets. The objective is to reduce the probability of producing dominating miners. Each miner can choose to compute one target or multiple targets. The intuitive logic is, if too many blocks are mined with the same target in a time period, then the difficulty of the target will be increased. The miners computing other targets will have a larger probability to mine a new block. Now, the challenge in developing such a framework is that we need to find a proper algorithm to adjust the mining difficulties for different computational targets to make it work. We anticipate such a framework will be ready for release sometime in 2021. I hope you all like this. There's more to come, so please stay tuned.